Hi, hello everyone. Myself, I am Rajesh H.M. I am studying in Sri Venkateshwara College of Engineering, Bengaluru. Now let us discuss about the presentation on the types of corrosion and methods to control corrosion. What is corrosion? Corrosion means destruction of the metal or alloy surrounding environment through the chemical or electrochemical reaction. It is basically defined as a natural process that causes the transformation of the pure metals into the undesirable substances when they react with the substances like water or air. This reaction causes the damage and disintegration of the metal, starting from the portion of the metal exposed to the environment and spreading to the entire bulk of the metal. There are the two types of the corrosion. One is differential metal corrosion and another is differential aeration corrosion. First one is differential metal corrosion. Differential corrosion when occurs the two dissimilar metals are in contact with each other and exposed to the corrosive conducting medium. The metal with lower electrode potential acts as anode and it undergoes the oxidation and get corroded. The metal with higher electrode potential acts as cathode and undergoes reduction and protected from the corrosion. This type of corrosion is also called known as galvanic corrosion or differential metal corrosion. The rate of corrosion depends mainly on the difference in the potential between two metals. The higher difference faster is the rate of corrosion. The reaction may be represented as anode. M gives rise to Mn plus electrons. The cathode reaction is reduction reaction takes place depending upon the nature of the environment. 2H plus 2 electrons gives rise to H2. 2H2O plus O2 plus 4 electrons gives rise to 4OH minus. For example, when iron is in contact with copper, iron becomes anodic and undergoes corrosion. When copper becomes the cathodic and remains unaffected. Tin coating copper vessels, steel pipe connected to the copper plumbing, bolts and nut made of the different metal. Another is differential aeration corrosion. When a metal is exposed to the different concentration of air or oxygen, a part of metal exposed to the lower concentration of oxygen became anodic and undergoes corrosion, whereas other part of the metal exposed to the higher concentration of oxygen become the cathodic and remains unaffected. This kind of corrosion is also called known as differential aeration corrosion. The anodic and cathodic reactions of the differential aeration corrosions are the at anode Fe is to Fe2 plus 2 electrons. At cathode 2H2O plus O2 plus 4 electrons gives to 4OH minus. Fe2 plus 2OH minus gives to FeOH twice. For example, a part of Nile inside the wall undergoes corrosion. When a dust particles sits on a metal bar, the part undergoes the dust undergoes corrosion. There are the two types of the differential aeration corrosion. One is waterline corrosion and another is pitting corrosion. First one is waterline corrosion. It is observed in steel or iron water tank partially filled with water when a steel tank is partially filled with water for a long time. When the inner portion of the water tank below the water line is exposed only to dissolved oxygen, whereas portion above the water line is exposed to the more oxygen. Thus, the portion below the water line act as anode and undergoes corrosion. The upper portion acts as cathode and it is unaffected. A distinct brown line is formed just below the water line due to the deposition of rust. The cell reactions are at anode M gives rise to Mn plus electrons. At cathode 2H2O plus O2 plus 4 electrons gives rise to 4OH minus. Finally, the ion combines to the form of corrosion product. For example, ship which remains partially immersed in seawater for a long time undergoes waterline corrosion. Another is pitting corrosion. This type of corrosion is observed when dust particles or oil drop deposits over the metal surface. The pitting corrosion is due to the metal surface is not a homogeneous, the external environment is not homogeneous. Crystallography directions are not equal in the reactivity. The environment are not uniform with respect to the concentration. Pitting corrosion results when the portion of the metal covered by the dust when it is less irradiation becomes anodic and undergoes corrosion. When it is formed pit, the remaining area of the metal when it is exposed to the higher concentration of oxygen becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because the formation of anodic area pit to corrode faster because accepting electrons from the cathodic area increases. The cell reactions are at cathode Fe gives to Fe2 plus 2 electrons at cathode of O2 plus H2O plus 2 electrons gives to 2OH minus. The total net reaction is Fe2 plus 2OH minus gives rise to FeOH twice. The methods to control corrosion. What is galvanization? The process of coating zinc on the base metal Fe, steel surface by hot dipping is known as galvanization. The galvanization process is carried out as follows. The metal surface is washed with organic solvent CCl4, toluene, benzene to remove organic matters. The metal surface is treated with dilute H2SO4 to remove rust and other deposits. Then it is well as washed with the water and it is air dried by the passing with hot air. The metal is treated with a mixture of zinc chloride and ammonia chloride, solution which prevent the oxidation of coated metal. Then the metal is dipped in the molten zinc at 4500 Celsius. The excess of zinc on the surface is removed by passing a pair of hot rollers, which removes the excess of zinc and produces a thin coating. The applications of the galvanization. Galvanized material are used in the fencing wire, buckets, bolts, nuts, nail, screw, etc. Galvanized sheet cannot be used for the preparing or storing food because zinc dissolved in acidic medium and forms toxic compound. To galvanized sheet metal, to galvanized household items such as buckets, tubs, and other container. To galvanized mission parts, tools, ships, tanks, and wires. The metal pipes and wires are most popular galvanized items which finds applications in the industrial use as well as in the articles made for the domestic use. Thank you.